All right, coding challenge time. Just a reminder, the stream is for entertainment purposes only, and let me quickly check if everything is up and running. So, seems like that. All right, let's see what we've got today. Chances are it's another hard problem, so I'm not sure still how this randomizer works, but maybe it just hates me already. I don't know, but let's see. Pick one. And no way, again, hard problem. Given an array of points containing the coordinates of points on a 2D plan, sorted by the x values where points I is xi, yi, such that xi is less than xj for any I less than j. You're also given an integer k. Find the maximum value of the equation where xi minus xj is less than k. Right, I'm already confused, sorry. I didn't follow. So the maximum value of the sum of y's plus the distance between xi and xj, right, where such distance is less than k or equal to, and j points length is guaranteed that there exists at least one pair of points that satisfy the constraint less than k. Well, I mean, the trivial is just quadratic complexity, right? This is, I guess, not the way you want to solve it, especially if it's sorted. So we want maximize the sum of y's plus whatever distance between two, right? Get insert and force matrices it can give the value of 10. No other pairs is physical. So we return the max of 4 and 1, which is 4. Minus 10. So y's can be negatives. And x would imagine can be negative, but it doesn't really matter because the distance is always positive. So this part is always positive, and y's can be negative, so which is maybe changes something, maybe doesn't. I don't know. xi form a strictly increasing sequence. Okay, that's good. Points I0 is less than points J0, which means x, right? Again, k is from 1 to 10 to the power of 20 million. It's a lot. And the length of the array is 10,000, okay. So give some rooms. Points, both can be minus 10 million to 10 million, whatever it is, who cares. So yeah, and always fixed length. Okay. Whiteboard. So they keep implying that the array is sorted, right? So this is definitely something we want to use. All right, let me see. Let's draw whatever they suggest in the example one. No, it can be negative as well. Damn, whatever. So the first point is 1, 3. Roughly speaking, is this one. Then second one is 0. All right. So the fifth one, 3, 4, 5, is 10. All right. So jump, should say it's 5, and that's as you logarithmic scale here. 10, and the sixth one is minus 10. Right, so we bounded by distance of 1, right? And again, the first part seems like, oh, why don't we just, find the max, then along the max, find the next two, all right? And so it's a pair, right? Should we go to the second max? Should we, okay, so the different question, should we sort it by value? Again, this example is too tiny, I would say. It gives us idea that we need something smart. So what gives us this ability of strictly sorted data points? Basically just one thing, that whatever point we consider, right, we can consider its E epsilon that is less or equal to K, knowing that, let's say, 2 points back is the maximum we can go far back, and 2 points forward is the maximum we can go forward, right? So gee, we can try to have a queue that is sorted by the value, started from the maximum y to the less maximum y, and for every value we sort in k. The problem, though, is that k neighborhood can be actually way larger than the number of points we have. So it will be k times n log n, right? Where this is what, 10 to the 8, and this is 10 to the 5. So technically it's just n squared log n. So, and if it's n squared, we don't need to do anything. We can just, directly search it, and that will be quadratic one. I would imagine there should be something we can do without relying on k itself. Mm-hmm. All right, let me, just for fun, to write the quadratic algorithm first. Because to me, it sounds like it's perfectly doable. So let's see. So we start with the leftmost and go this way, right? And because it's symmetrical, we never go backward. So it starts with int, let's say I equals to 0, right? And we know that this is the lowest in terms of x element. I less than points, size, I plus plus, right? So the first one is simple. The second one is for in j equals to I plus 1. So the next one, we cannot use the same point. It's strictly increasing. This is guaranteed, right? J less than what? Than minimum between point size and k, because we no need to look more than k, right? Or maybe k plus 1 in this case. So let's say if k is 1, right? It, uh, and this is 0. Yeah, let's say k plus 1. So this is, so then let me say j plus plus, right? And all we do, so int max question, and again, it can be negative. So um, mean int, I believe. This is what it is, right? Int cpp. Int mean, sorry. Yeah. And this is very dumb. What all we do is max question. And because it always depends only on 2 points, so it's like, whatever. Let's just do these points. I1 plus points. This is not k. This is not k, right? Or points j of of 0 That's what it is. So we don't need this, right? Now points J1 plus, so we know that this is strictly increasing, so we don't need even apps, we can just say plus um, this minus this, all right? It's max of max equation in this thing. So I doubt it's so dumb. It might work though in small scale examples because it's not quite. Mm, yes, but there is no way we can pass the complexity check. Interesting. How come? Um, all right, let's do interest equal to this, right? It's just sum of y's plus distance. Should it be or? So this should be true, right? All right, let me just check without this first. Mm. Wait a second. It's not like this. The difference between them should be less or equal to k, right? So we should say this. Mm-hmm. Now it works. Now, all right, at least we will pass some simple checks with dumb quadratic. Yeah. Time limit exceeded, so how much test did we pass? Obviously, 63 out of 65. Wow, almost complete one score. All right, so we have more than 20 minutes. Let's see. First of all, let's just see what's the topic here. Sliding window. Nice. So we have a window of k where we maximize this element, right? And track what are the indexes correspond to the window k. Then we move k by 1 and we see if it changes something there, right? If at least it's if it's great or not, then we read. So within this window k, we have basically two numbers that are already the best, right? Once we move it by 1, but then the question is, if we add new element to this k window, right? It's easy to say that it's easy to check if we change the maximum, right? But if we remove element, we don't know what the maximum is because the k can be very large. Right, so let's see the hints. Priority queue to store each point in a tuple. It's a very bold hint. It basically tells us the algorithm, right? Like the data structure that you should use. Yi minus xy. Wait, I don't understand why. Because we subtract x, technically, I, right? So, and then use this q within the sliding window to solve it, most likely. Right. Let's see on the whiteboard if these hints are sufficient for us to solve. We have two more hints, but we don't have time, I guess, left. But yeah, I got it. So we have priority queue. Let's say in this case, we have 2, right? 2, which is 3 minus 1, 1. Then we have what? 0 minus 2 minus 2 and 2. And then we have what? 10 minus 5, which is 5. Sorry. Then 5. And then we have minus 10 minus 6 minus 16 and 6. So if I would sort it, this will be the first, then this, and then this. So, okay, I don't see how the sliding window can be combined with this queue. So the idea is if I feed this element, right, at 1, I can compute, so 2 of them are not part of it. So say I do 5, so the only one can be minus 16 here. Yeah, I don't understand how priority queue will be part of the sliding window. Interesting. What's sliding window then? Loop through the array and pop elements from the heap in the condition that xj minus xi greater than k. So we're preparing sort of the queue for all non-valid elements, but I don't understand where j is the current index and I. So we go in the loop, like the loop we have here. So here's the hint. So we go through this loop and we have this queue, which is kind of our k window. We pop all elements that are outside of this k window for given index, let's say j, right? So it's now j. And then, okay, so let's say I started with 0 element here, or with xi equal 1, right? So I will remove this and this, and then, all right, so there will be some elements in the queue, but I would imagine the point on top of the queue, I will skip it, I guess. And then, okay, see the last hint, and I guess it just solves the problem now. The queue is not empty, calculate the equation with the current point and the point on top of the queue and maximize the answer. Because it's the best for you. I see. We don't know when we're sliding window. Remember I said we don't know which element to enter, which element do not. The key solution here, I guess we have time to try to implement it, but the key solution here, it's not interesting already because they already said everything. Key solution here is to look to these yi minus xi, right? So this is your key. So we start with the best one. So this is maximizes your yj plus, because we know that xi is always less than xj, so xj plus yi minus xi. So obviously when we max this thing, right, we now can split it to these two, max here and max here. So that's what we do. That's what we do. All right. Okay, let's do this. So should be straightforward. Priority queue of what if? I guess by default we can just say pair of int and int queue or pq PQ, then we do first I, right? Exactly. Then we say but then it's interesting if I want to return elements back to the queue. Once I pop them out, should I push them back once we move to the next element? This is interesting, but let's see. I think we should. This would be the only thing to do. So PQ, I think it's push, make pair, and this will be points I1 minus points I I0, right? This is the difference. And obviously the second one will be just our I index. So we know which number is it, right? So because using I, we can always access the actual X. It's not the problem. All right. So let me check quickly. Priority queue is what I'm looking for here. Priority queue pair. I guess the default will be ordered by first, and it will be 20 and then 100. Because 20 is the maximum. Yes, correct. So yeah, that's it. So once we have this, we go through the J now, right? So we don't need this because we already have one result here. So let's see. So now I think it's simple. So we have, let's say, vector of, actually we can, we don't need to push them back. So the thing is, we, no. So it can be some element that is further away, right, from the current point. So if I push it back, if I pop it away from the queue, then I move to element that is now in the range of k with that element that was the better option. I might be better off, right, in terms of solution. So yeah, I think we need it. So let's just say vector of pair and int better options, right? So what do we do? While PQ top second is the index, so it's pay points points. Yes, so basically we check this, right? while points j0 minus points I pq top second greater than k, we say pq, okay, better options push back pq top and then pq pop, right? So then we do uses this, right? Where now all we need to do, so we have j, right? Like this, and this is pq. If pq empty, right? Not, if pq not empty, then we say this. If pq is not empty, then we say pq top, and it's plus top first. All right. After that, we say while better options empty, not, all right. We say pq push, and better options I guess better options. Pull back, right? So looks like this. The problem though, okay, I'm uncomment this thing just to check. Okay, we don't have ij, but let's say j. We have I. The I is pq top second, right? Let's or PQ top second and second not equal j. So if we let's say less than k, right, at the top, but it's equal to j, then we still pop it, I guess. Let's see if we correct here. Run the code. Points I. Where is this? Line 11. So it's here. Oh, it should be this and 0. Right. So we're about the end of the time. And to go to push. Is it only removes element? So I guess you should do back, and then you should do better options, pop back. Something like this. No way. Right, so we start with 2. Seriously? Okay, so yes, second element is this one. Obviously, it will be 5, as we said, it will be the first one. That it should be never part of the solution result 9. Then it's even weirder. So we go to I2, J2. And at this point, it's just ridiculous. Oh, man. PQ points J 0, which means 1 minus top second, which is 2, right? Greater than k, and PQ top second not equal j, and it's not equal. We say better option push back, PQ top, and then PQ pop. So I just wonder how come. Actually, we don't need this at all. All we can check is that no, we need to, I guess. Right, so we should also remove it. So k is 1. So we say 2 minus 0 is 2 is greater than k. So we should remove element from the top. And then we get to the second one. It's not greater than k, but it's equal to j. So we should keep going. Am I missing something? Oh, that's why. That's why. Because here we don't know the order, so we need to take apps. Now it's better, but we still hit this J0, I0 situation, which should never happen. So once we exclude these two, we will left with 4 and 1, and that's it. So why on earth we do not push back? Greater than k. If not, equals j maybe. Let's see. Run code. Yeah, these logical operations, not great. Okay, then it breaks here. So it looks good overall. By the way, what will happen if I won't do this? I just wonder. It still works. So because we go this side. Yeah, we just popped it and that's it. So we left with 1, then we go to 3. 1, 2, 3. So the third element, for some reason, which is the last one basically, we left it in the queue? How come? Distance is 6, right? For, and PQ, while the difference is greater than K, I just say PQ pop. Interesting. Oh, because it was not at the top, so we never removed it actually. We stop at 0. And yeah. So yeah, we run out of time, but basically all we need is just to debug this, and most likely it will pass, obviously with all hints and stuff like that. And that's okay for hard problems, I guess. Why it's so difficult to understand why it returns the same Q at the top. So, okay, I removed 1. It shows me 0 element here. So I'm saying the distance is greater than K? No. So it's false, right? It should be or, right? So if it's false, and this is or second equal to J, this is why logical operations are bad. The time, so it returns 4 now. Okay. All right. So 3 and 2, 2 and 3. So it checks. What's the point of checking 3 after 2? I wonder. So let's see if we do need to push it back to the queue. So in this case, maybe we don't, and still return the right solution. No, it doesn't. It shows time limit exceeded. Interesting. Why? Because Q becomes empty and nothing to do, right? So if PQ empty break, if no, it's not here. It's so but it should be empty, right? So we should never enter here if PQ not empty. So we just should cycle quickly and that's it. I wonder if it's here something is while PQ empty, PQ not empty, and one of those holds, right? Almost there. Yeah, now we just check one solution, which is for zero element. We check the first one, so others will be removed. And it says result 2, although we may not worry about this, like, right? All we can say is, let's just do this, okay? So let's just do whatever here, plus, so this is 1, plus abs, so we don't care the order or anything, so it's just this way of compute stuff. All right, so this we compute res and run the code, and then it should return 4, but it won't check the second point, which is wrong. So I would imagine we still want to do this better. Options back and then push back. Right. So okay. This looks slightly better. Seems like that. Okay. So with all those hints, seems like we solved it. But again, no guarantees we pass through time limit because we still, yeah, technically we run through one cycle here, but then we mess with the queue. So we remove the point, add the point, remove the points, add the points. So I'm not quite sure. So to me, this is still acts less like quadratic because you see while PQ is not empty, right? So the worst case, we go through all elements except maybe one there, if only one pair is guaranteed, and which means the complexity is quadratic. And then we push it back. It's even worse actually than quadratic. It's quadratic times log of n. So it's n squared log n. Maybe not. But let's see. Let's comment out and submit. Yeah, that was obvious. So it's still, there's still something missing, right? And maybe we don't really want to check all the points. Let me just do this quick thing, right? Maybe the fact that we use Q guarantees us that the best element there, but then what if something better on the right side? We don't know. Should it be vice versa? Should it be like we start with the best element in the queue and we go through all elements that are not that are within K range, then we remove it, then we go to the next K range can be big. Yeah, I don't really know. Whatever. Let's try and see. But most likely it won't give us the right solution. So we already have this almost completed mission, right? Run the code. Obviously, in this case, it will return 4 due to order of elements, but it will fail some checks 100%. Mm-hmm. Yeah. All right. So we failed, but we passed 63 out of 65. Let's quickly check. Priority queue, 14 lines. Mm-hmm. So PQ not empty. Ah, it's in one cycle. Interesting. So you don't need to file it first. So you add it, then you move. Interesting. Interesting. And this is passes now. Right. So basically, that's what we've done. And because we do not add it, so we start like with one, then we go to the second one, right? And then we check third one, and then we check the best one for I see. So that was easier, way easier, actually. And we don't need these check now. What we need to say is this. And then we don't need this, we don't need this, and we don't need this. This is not empty, and all we need to say is PQ, push, okay, too much of code deletion at once. So this is J actually. And then we don't need this, don't need this, don't need this, don't need this. Yeah, makes sense. All right, it doesn't count, although we solved it just using the code. So yeah, screwed everywhere. It wasn't easy to figure out this. It's kind of piece of dynamic programming a little bit. They tell you, you know what, look at your max function, see what's there and understand that these tiny pieces, this is the way how you want to order the elements. And once you know this, then you should understand that actually if I start one by one, start with first element, I just add it to the queue, then go to the second element if it's within the range. I pop it and it's guaranteed to be the best. Then I go to the third element, right? then it's still within the range with the first one. So I can again reuse the first one to update the max. If it's already not, I pop it and then move it to the second one, which was the prior element, and so forth. So this is how I do this sliding window with this smart queue sort of thing. All right. Damn, it wasn't obvious, like at all. So we used all hints, and after all, we still went through the discussion. Oh man. This way, these problems make you, feel dumb, which is a good feeling, by the way. Otherwise, you won't be able to progress in problem solving if you don't solve the problems. And at least you're not trying to. So this is the best we've got today, is our quadratic. Always whatever Q and hints we can. But this was achieved without the hints. So we solved the algorithm without the hints, but in boring way that obviously won't pass the complexity check. So let's stick with that and go to the whiteboard and just update. Another failure today. Yeah, not my fault. I wish I get easy problem every day with this stupid randomizer, but I don't. So I had to embarrass myself every day just for fun. Six, five, and oops, looks doesn't look pretty. So 6, 5 looks a bit better. Uh, almost there. I think I want something like, yeah, okay. Works. See you next time.